Hello and welcome to this video where we're going to be talking about the Earth model basics. We're going to make the absolute basic Earth model. Some people would call it the poor man's Earth model. And we're going to be working only what we call physical properties. By physical properties, we mean properties that can be related one-to-one to a log, to a well log. So this is where we were. And we had identified an area that was of possible interest. So I'm going to zoom in here, and I'm going to clear the selection, and I'm going to set the modeling limits to the current view. So this is going to be the area where we're going to be actually working. Only this area where it seems like there's gas is where we're going to be working. And the first thing we're going to do is we're going to add some boundaries. To do this, there's a couple of ways to do it. You can click here in the boundaries icon and you get this module. You can select either if you same type of source, either by gamma ray directly, or we can use any of the logs. I'm going to use AT10. I'm going to use the resistivity logs because I know that there's a little more signal in this case. Now I detected, but we don't see anything. Well, because we don't have a plot for the gamma rays. Sorry, for the boundaries. So we need to go and add Earth model, and now we have that plot here. And that gives us a good starting point. I'm just gonna go here over this module a little. You select the source, so the log that you're gonna be using, and then we have a number of methods. Maximum variance is probably the most common. Step function is very similar, but in general, I think it gives you slightly better results. Not too big of a deal. And you can use one or you can use multiple logs if you want to, and you can decide what is the minimum layer thickness and other cool things. You can also show the layer thickness as a histogram once it's done. In this case, not too interesting, but in cases where you have a larger modeling interval, that's going to be interesting. And very importantly, you can load boundaries and tops. If you just click here, it shows you what that is. Shows you the format of the file. In some cases, you have them in TVD. You can load them using this. Or if somebody else already did this and you're supposed to have the boundaries at a specific location, you can do this. Anyway, now that that's done, we have some layers, and that looks good. And I'm going to, they may look good. I'm going to copy and paste the boundary plot everywhere. This was just a track that we added. I'm gonna delete it. Notice that you also have a right-click context menu up there. And this is what we're interested in right now. We can also modify them a different way. For example, with controls that we have down here. All the controls that you have here, for example, this plus P is to create petrophysical boundaries. The arrow with the plus is to create boundaries. The difference between those two is just that the boundaries are more for fluid properties. And at this stage, it doesn't make really any big difference, just use petrophysical. When we start looking into fluid flow and those modules, it's going to be more relevant. So for now, we stick with this. You can delete them. You can move them. You can just move them to whatever location. And these two arrows are the undo and redo. If you think you've made a mistake, you can undo it or you can redo it. I'm just gonna add some boundaries. They need to be perfect for this matter. Now we have the gamma ray, the porosities, and the resistivity with some boundaries. Great. Now, something else that is important is besides boundaries, we have something else. I'm gonna make a little parenthesis here. In the very left, you've seen that we have this formation zones track. You can load you can specify formation zones by clicking in this colorful icon or Earth model formation zones, and you should bring this module. So I'm going to add a new formation zone. I'm going to call it gas sandstone. And I'm going to say that it starts over here. So roughly 9342 or something like that. And I just say, okay, now we have the gas sandstone. And you can change the color. You can modify things. We could make it finish and have something else. You can even have the same one again in cases. For example, I could say, well, actually, I want formations of one back here. You could do that. But anyway, it doesn't really matter for this purpose. It's just to give you an idea, to let you see that you can have another reference, and that's always going to have a boundary here that is related to it. Okay, now back to the boundaries. We had the boundaries here, so because we added that boundary, I can probably delete the other one, and we can either keep this one here, or I'm going to make it a little higher where it seems like it might be. And you can see that the formation zone was also modified when I moved it. If I move it down, the formation zone moves down. You can interactively move that. Great. Now we are going to elaborate more in the properties. Right now we have resistivity. This is the log resistivity. This is the gamma ray log. But we also have something called the Earth model gamma ray and the Earth model resistivity. So first I'm going to go to the gamma ray log, and we don't need this. I'm just going to add another plot, but this plot, oh, sorry, not that one, not another track, just another plot here in gamma ray. I'm going to add another log plot, which is going to be an Earth model, and is going to be gamma ray. And I'm going to make sure it's green just to match it with what I have. And it's not showing. It's telling us that gamma ray, if you look at the bottom, or if I turn this on to see the values, you can see that it's at 0. It's at 0 because the default value for gamma ray is 0. So we don't really see it. So to be able to see it, what we're going to do is we're going to do something called populate properties. So we go here in the module, either Earth model, populate properties, or alternatively this icon that has the what looks like a log there. Now here, I'm going to say, I'm going to populate the property gamma ray using the mnemonic gamma ray. And when I do that and I hit populate, now I have this. You can see now it's actually showing. I'm going to make it a little more clear. To make it a little more clear, I'm going to make it a little thicker. You can clearly see where it is. If we go back into the populate properties, we can see there's a few options here. Well, there's also populate minerals. There's a few methods. The one that is most commonly used is trend extreme, that just takes the maximum or minimum depending on what the log is doing in that layer. Then we have mean or the middle of layer. Those are the main possibilities that you have. In many cases, middle of layer is actually pretty accurate. Some people prefer that over trend extreme. And it just shows you, I can do it and you can see how it's slightly different, but I'm going to stick to trend extreme in this case. Now, we're going to do the same, but also for resistivity. So we're making an Earth model that consists only of the properties gamma ray and resistivity. But we can see there's some invasion. So we need some radial zone. So I'm going to click here to add another radial zone. And now you can see that for resistivity, you have now mod, invaded, and formation. So for example, I'm going to say 8010 is the one that is higher up here. It reaches 30 or so. So I'm going to say that for resistivity in the mod area is going to be an explicit value of 200. Just 200 ohm meters, because it looks like it's oil-based mod and it's a value that we could work with. Then for resistivity in the invaded zone, I'm going to use the LAS, and I'm going to use 8010. So I'm going to use what we have here in 8010. And that's okay. Then for the formation, I'm going to use LAS, and I'm going to use 1890. And then I can populate. And now that we've done that, I can see, well, we don't see any changes. Of course, we don't have any plots. So I'm going to add a plot with LAS. Sorry, not LAS, but the Earth model. And now, again, it's the same type of source. So I'm going to look for Earth model resistivity. And we have resistivity parallel or homogeneous. we're not dealing with anisotropy, so this is good. And we have the formation, which is here matching 1890. I'm gonna use the same color or something similar. And then I'm going to add another one for not the formation, but for the invaded zone, which is going to be here in the blue. And we can see that now they're matching. And that's basically the poor man's Earth model. Now, there's another way that we can see the Earth model when we have invasion. I'm going to add another track. And in this track, we're going to add another type of plot, which we call the vertical cross section. And what that means is that it has, in the very left is the borehole. Then you have the layers like you have in the other zones, but you have a radial zone. So this from here to here is 0 to 2 feet distance. And you have the invaded zone and the virgin zone. I'm going to make it a little bigger so that it looks a little better. This is resistivity, so I'm going to make the limits. These are the limits for the resistivity, so maybe something like that. And instead of linear, I can make it logarithmic. You can change the color map. Perula is what MATLAB uses by default. Some people prefer Jet, which is the old style. And some people prefer something a little more single color or even gray. It's up to you. Radial scale can also be modified. The units, all those things. You can show boundaries or not. And this way, it's you can see how the radial zone is, how the invasion profile is looking. In this case, it's just flat because we just added one, but we could modify it. If you click in the same icon that allows you to shift the layers, it allows you to shift the position of the layers here or the boundaries, and also the radial boundary. So you can, if you say, well, there must be more invasion here, or there must be more invasion here, or whatever, something like that, you can modify it here. And that's the minimum for Earth model properties. And you can do the same for any property that has an equivalent, including photoelectric factor, including neutron porosity, that in the source is migration length, but neutron porosity is fine. You can have density. You can have density. You can have all multiple properties that have those equivalences. And we're going to look into how can we refine this model even more in cases where you have invasion or where you have thin layers or things like that. All right. Thank you. And I'll see you in the next video. Also, remember that besides this exercise, there's another exercise that you can do following the link in the description. You can continue with the exercise you had in the previous session.